Alexander Fleming, the accidental discovery that saved millions. Imagine a world where a small cut on your finger could kill you. Imagine hospitals filled with people dying from infections that today we can cure with a simple pill. Now imagine a Scottish scientist who accidentally left a dirty plate in his laboratory and changed medicine forever. This is the remarkable story of Alexander Fleming, the man who discovered penicillin and gave the world the first antibiotic. Fleming's discovery was one of the most important accidents in human history. Before antibiotics, millions of people died from infections and diseases that are now easily treatable. Fleming's work saved more lives than any other medical discovery in the 20th century. He proved that sometimes the greatest breakthroughs come not from careful planning, but from being curious about unexpected results. Fleming showed the world that a prepared mind can turn a mistake into a miracle that benefits all humanity. Before we explore Fleming's incredible journey, please remember to subscribe to our channel, Beginner Bio Stories. We create simple English stories about famous people to help you learn English, while discovering the lives of extraordinary individuals who made our world better. Now, let's discover the amazing story of Alexander Fleming, the scientist whose accident became one of the greatest gifts to human health. Early life in rural Scotland. Alexander Fleming was born on August 6, 1881, on a farm called Lochfield in Darvel, Scotland. He was the third of 4 children born to Hugh Fleming, a farmer, and Grace Morton Fleming. The Fleming family lived in a remote area of southwestern Scotland, surrounded by rolling hills and green fields, where sheep and cattle grazed peacefully. Fleming's childhood was spent in the beautiful Scottish countryside, where he learned to love nature and observe the world around him carefully. He helped his father with farm work, taking care of animals and learning about the cycles of life and death that are part of farming. This early experience with nature would later help Fleming become an excellent observer of natural phenomena. The Fleming family was not wealthy, but they valued education and hard work. Hugh Fleming believed that his children should have opportunities to learn and improve their lives beyond farming. He encouraged young Alexander to study and think about the world beyond their small farm in Scotland. When Alexander was 7 years old, his father died suddenly, leaving the family in difficult financial circumstances. His older brother Hugh took over the farm, while their mother Grace worked hard to keep the family together and ensure that all the children could continue their education despite their reduced circumstances. Alexander was a bright child who loved reading and learning about science. He attended the local village school, where he showed particular interest in natural history and biology. His teachers noticed that he had an excellent memory and could understand complex ideas quickly. Alexander was also very observant and curious about how things worked. At the age of 13, Alexander left home to continue his education in London, where his older brother Tom had already moved. This was a big change for a boy who had grown up in the peaceful Scottish countryside. London was a huge, busy city with millions of people, noise and pollution that was very different from his quiet farm life. In London, Alexander lived with his brother Tom and attended Regent Street Polytechnic. He studied business subjects because his family hoped he could find a good job in the city. However, Alexander was more interested in science than in business, and he spent much of his free time reading about biology and chemistry. After finishing his studies at the Polytechnic, Alexander worked for 4 years in a shipping office in London. The work was boring and repetitive, involving keeping records of ships and cargo. Alexander felt that this job was not using his talents or satisfying his curiosity about the natural world. He dreamed of doing something more meaningful with his life. The path to medicine. When Alexander was 20 years old, he inherited some money from an uncle who had died. This inheritance gave him the opportunity to change his life completely. Instead of continuing to work in the shipping office, Alexander decided to use the money to study medicine at St. Mary's Hospital Medical School in London. Fleming's decision to study medicine was influenced by the Boer War in South Africa, where British soldiers were fighting and many were being wounded. He was impressed by the work that doctors and surgeons were doing to save lives and help wounded soldiers. Alexander felt that medicine would allow him to use his intelligence to help other people and make a real difference in the world. St. Mary's Hospital Medical School was one of the best medical schools in London. The curriculum was demanding and required students to learn anatomy, physiology, chemistry, and clinical medicine. Alexander proved to be an excellent student who could memorize large amounts of information and understand complex medical concepts quickly. During his medical studies, Alexander became particularly interested in bacteriology, the study of bacteria and other microorganisms. At that time, scientists were just beginning to understand that many diseases were caused by tiny organisms that could not be seen without a microscope. This was a new and exciting field of study that attracted curious minds like Fleming's. Alexander graduated from medical school in 1906 with excellent grades and several prizes for academic achievement. He had originally planned to become a surgeon, but fate intervened in an unexpected way. A professor named Almroth Wright, who was one of the leading bacteriologists in Britain, offered Alexander a position in his research laboratory at St. Mary's Hospital. Professor Wright was working on developing vaccines and studying how the human body fights infections. He needed bright young researchers to help with his work, and he had been impressed by Alexander's intelligence and curiosity. Although Alexander had planned to practice surgery, he decided to accept Wright's offer and begin a career in medical research. This decision changed the course of Alexander's life and ultimately the history of medicine. If he had become a surgeon, he might never have made the discoveries that would save millions of lives. Sometimes the most important decisions we make are the ones that take us away from our original plans and toward our true destiny. Working in Wright's laboratory, Alexander learned sophisticated techniques for growing bacteria in the laboratory and studying how they behaved. He became skilled at preparing culture plates, examining specimens under microscopes, and conducting experiments to test hypotheses about bacterial growth and infection. World War I, treating infected wounds. When World War I began in 1914, Alexander Fleming served as a captain in the Royal Army Medical Corps. He worked in military hospitals in France, treating wounded soldiers who had been injured in the terrible battles of the Western Front. This experience had a profound impact on Fleming's understanding of infection and disease. Fleming saw firsthand how many soldiers died not from their battle wounds, but from infections that developed after they were injured. Even soldiers with relatively minor wounds would often develop severe infections that spread throughout their bodies and eventually killed them. The medical treatments available at that time were not effective against these dangerous infections. The hospitals were filled with young men who were dying from infected wounds, pneumonia, and other bacterial diseases. Fleming watched helplessly as soldiers who might have survived their injuries died, because doctors had no way to fight the bacteria that were killing them. This experience made Fleming determined to find better ways to prevent and treat infections. During the war, Fleming learned about the work of Paul Ehrlich, a German scientist who had discovered chemicals that could kill bacteria without harming human patients. Ehrlich had developed a treatment for syphilis, proving that it was possible to find magic bullets that could target disease-causing organisms while leaving healthy tissues unharmed. Fleming was fascinated by the idea of finding substances that could fight bacteria inside the human body. He began to think about how nature might have already developed such substances. Since plants and animals in the wild rarely died from bacterial infections the way humans did in hospitals and cities. After the war ended in 1918, Fleming returned to his research work at St. Mary's Hospital. He was now more motivated than ever to find ways to fight bacterial infections. The horrors he had witnessed during the war had convinced him that this was one of the most important problems facing medicine. Fleming began conducting experiments to test various substances that might have antibacterial properties. He tested everything from plant extracts to chemicals, looking for anything that could kill bacteria without harming human cells. Most of his experiments failed, but Fleming was patient and persistent in his search. In 1922, Fleming made his first important discovery. He found that human tears, saliva, and mucus contained a substance that could kill certain types of bacteria. He called this substance lysozyme and showed that it was the body's natural defense against some infections. This discovery proved that nature had indeed developed ways to fight bacteria. The accidental discovery of penicillin. The discovery that made Alexander Fleming famous happened by accident in September 1928. Fleming had been growing bacterial cultures in his laboratory to study how different bacteria behaved and multiplied. He was working with a type of bacteria called Staphylococcus, which causes many serious infections in humans. Fleming was not the most organized scientist in the world. His laboratory was often messy, with culture, plates, and equipment scattered around on benches and shelves. Some of his colleagues criticized him for being careless, but Fleming's messy habits actually contributed to his greatest discovery. Before going on vacation in August 1928, Fleming had been working with several culture plates containing Staphylococcus bacteria. Instead of properly cleaning and storing these plates, he left them stacked on a bench in his laboratory. When he returned from vacation in September, he began examining the plates to see what had happened to the bacterial cultures. On one of the plates, Fleming noticed something very unusual. A mold had somehow contaminated the plate and was growing alongside the bacteria. This was not uncommon in laboratories, and most scientists would have thrown the contaminated plate away and started over with a fresh culture. However, Fleming was a careful observer who had trained himself to look for unexpected results. Instead of discarding the plate, he examined it more closely under a microscope. What he saw was extraordinary. Around the mold, the bacteria had been killed. There was a clear zone where no bacteria were growing, as if the mold was producing something that was deadly to the bacteria. Fleming realized that the mold must be producing a substance that could kill bacteria. This was exactly what he had been searching for during his years of research. The accidental contamination of his culture plate had revealed a natural antibiotic that might be able to fight infections in human patients. Fleming carefully preserved the contaminated plate and began studying the mold that had produced this remarkable effect. He identified it as belonging to the genus Penicillium, so he decided to call the antibacterial substance it produced penicillin. He began growing the mold in larger quantities to produce more of the active substance. Fleming's initial experiments with penicillin were very promising. He found that it could kill many types of harmful bacteria while being relatively harmless to human cells. He tested it on laboratory animals and found that it did not cause serious side effects. Fleming had discovered the world's first true antibiotic, struggling to develop a wonder drug. Although Fleming had discovered penicillin, turning his discovery into a medicine that could be used to treat patients proved to be much more difficult than he had expected. The penicillin produced by the mold was very unstable and lost its effectiveness quickly. Fleming also had difficulty producing large quantities of the pure substance. Fleming published a scientific paper about his discovery in 1929, but the medical community did not immediately recognize its importance. Many scientists thought that penicillin was just another interesting laboratory curiosity that would never have practical applications. Some doctors believed that it would be too difficult to produce enough penicillin to treat human patients effectively. Fleming continued to work on penicillin throughout the 1930s, but he made only limited progress. He was a brilliant researcher, but he lacked the resources and expertise needed to develop penicillin into a practical medicine. The chemistry required to purify and stabilize penicillin was extremely complex and required specialized knowledge that Fleming did not possess. During this period, Fleming became somewhat discouraged about the prospects for developing penicillin as a treatment for human infections. He continued his other research projects and occasionally mentioned penicillin in his lectures, but he did not actively promote its development. Fleming might have given up entirely if not for the intervention of other scientists who recognized the potential of his discovery. In 1938, Howard Florey, an Australian scientist working at Oxford University, became interested in Fleming's work on penicillin. Florey was an expert in pharmacology and had the skills needed to develop Fleming's discovery into a practical medicine. He assembled a team of researchers, including Ernst Boris Chain, a German-Jewish biochemist who had fled Nazi Germany. Florey and Chain began working intensively to solve the problems that had prevented Fleming from developing penicillin as a medicine. They developed new methods for growing the mold and extracting pure penicillin from it. They also conducted extensive tests to prove that penicillin was safe and effective for treating infections in animals and humans. The work of Florey and Chain was supported by British and American government funding. As World War II had begun, and there was urgent need for new medicines to treat wounded soldiers, the war created both the motivation and the resources needed to turn Fleming's discovery into a life-saving medicine. By 1942, Florey and Chain had succeeded in developing methods for mass-producing penicillin. Pharmaceutical companies in Britain and the United States began manufacturing large quantities of the drug, making it available to treat military personnel and eventually civilian patients around the world. World War II, penicillin saves lives. During World War II, penicillin proved to be one of the most important weapons in the fight against disease and death. Soldiers who would have died from infected wounds were now able to recover completely after treatment with Fleming's wonder drug. Penicillin reduced deaths from bacterial infections in military hospitals by more than 90%. The impact of penicillin extended far beyond military applications. Civilian hospitals began using the drug to treat pneumonia, meningitis, scarlet fever, and dozens of other bacterial diseases that had previously been fatal. Parents no longer had to watch helplessly as their children died from infections that could now be cured with a simple injection. Fleming was amazed and delighted to see his accidental discovery being used to save lives around the world. He had always believed that penicillin could be a powerful medicine, but even he had not imagined how dramatically it would change medical treatment. Letters poured in from grateful patients and families whose lives had been saved by penicillin. The success of penicillin during World War II led to intensive research to discover other antibiotics. Scientists around the world began searching for microorganisms that produced substances capable of killing disease-causing bacteria. This research led to the discovery of streptomycin, tetracycline, and many other antibiotics that further revolutionized medicine. Fleming became famous throughout the world as the discoverer of penicillin. He was invited to give lectures in many countries and received numerous awards and honors for his contribution to human health. However, Fleming was always careful to acknowledge the important work done by Florey, Chain, and others who had helped develop his discovery into a practical medicine. In 1945, Fleming, Florey, and Chain shared the Nobel Prize in Physiology or Medicine for their work on penicillin. This was the highest honor that could be given to medical researchers, and it recognized the enormous impact that their work had on human health and welfare. Fleming used his fame to promote scientific research and education. He believed that society should invest more money in basic research because it was impossible to predict which discoveries would lead to important practical applications. Fleming's own experience proved that even accidental discoveries could have tremendous value if they were made by prepared minds. The antibiotic revolution. Fleming's discovery of penicillin launched the antibiotic era in medicine. Before antibiotics, bacterial infections were among the leading causes of death throughout the world. Children regularly died from strep throat, adults died from pneumonia, and simple cuts could lead to fatal infections if bacteria entered the bloodstream. The introduction of penicillin and other antibiotics changed this situation dramatically. Diseases that had killed millions of people throughout history became easily treatable with simple medications. The average human lifespan increased significantly as deaths from bacterial infections became rare in countries with access to modern medical care. Fleming was proud of the role his discovery had played in this medical revolution, but he was also concerned about the potential for antibiotics to be misused. He worried that doctors might prescribe antibiotics unnecessarily, or that patients might not take them properly, leading to the development of antibiotic-resistant bacteria. In his later speeches and writings, Fleming warned that bacteria could evolve to become resistant to antibiotics if these drugs were not used carefully. He predicted that overuse of antibiotics could lead to the emergence of superbugs that would be difficult or impossible to treat with existing medicines. Fleming's warnings proved to be prophetic. By the 1960s, some bacteria had indeed developed resistance to penicillin and other antibiotics. This led to ongoing research to develop new antibiotics and to efforts to educate doctors and patients about the proper use of these important medicines. Despite these challenges, antibiotics remained one of the most important tools in modern medicine. They made possible complex surgeries, cancer treatments, and other medical procedures that would be too dangerous without effective ways to prevent and treat infections. Fleming's accidental discovery continued to save millions of lives decades after he first noticed that mysterious mold on his culture plate. Fleming lived to see the beginning of the antibiotic era and the tremendous impact his discovery had on human health. He remained active in research and education until his death in 1955, always emphasizing the importance of careful observation and being prepared to recognize the significance of unexpected results. Legacy of an accidental hero. Alexander Fleming died on March 11, 1955, at the age of 73. He had lived to see his accidental discovery transform medicine and save millions of lives around the world. Fleming was buried in St. Paul's Cathedral in London, an honor reserved for the most distinguished British citizens who had made extraordinary contributions to their country and humanity. Fleming's life story became an inspiration to scientists and students around the world. His discovery proved that important breakthroughs could come from unexpected sources, and that success in science required not only intelligence and hard work, but also curiosity, careful observation, and the ability to recognize the significance of surprising results. The Fleming story also demonstrated the importance of both basic research and applied research in advancing human knowledge and welfare. Fleming's initial discovery of penicillin was the result of basic research into the nature of bacteria and infection. However, the development of penicillin into a practical medicine required the applied research efforts of Florey, Chain, and many others. Today, Fleming's discovery continues to save lives every day. Penicillin and other antibiotics are used to treat millions of patients annually, preventing deaths from infections that would have been fatal before the antibiotic era. Modern hospitals, surgical procedures, and medical treatments all depend on the availability of effective antibiotics. Fleming's laboratory at St. Mary's Hospital has been preserved as a museum where visitors can see the place where penicillin was discovered. The original culture plate with the mold that started the antibiotic revolution is displayed as one of the most important artifacts in the history of medicine. Scientists continue to search for new antibiotics to combat the growing problem of antibiotic-resistant bacteria. Fleming's approach of looking to nature for substances that can fight disease continues to inspire researchers who are exploring everything from deep-sea bacteria to rare fungi in their quest for new medicines. Fleming's emphasis on careful observation and being prepared to recognize unexpected discoveries remains relevant for scientists today. Many important breakthroughs in science have come from researchers who noticed something unusual and had the curiosity and knowledge to investigate further rather than dismissing it as unimportant. The story of Alexander Fleming reminds us that some of the most important discoveries in human history have come from accidents and unexpected observations. However, these accidents only become discoveries when they happen to prepared minds that are trained to observe carefully and think creatively about what they see. Fleming's legacy also includes his warnings about the responsible use of antibiotics, as antibiotic resistance has become a growing problem in modern medicine. Fleming's predictions about the dangers of misusing these powerful drugs have proven to be remarkably accurate and far-sighted. Alexander Fleming's accidental discovery of penicillin shows us that curiosity, careful observation, and preparedness can transform even the most unexpected events into gifts that benefit all humanity. His story teaches us to stay alert to the possibilities around us and to remember that the next great discovery might be hiding in the most ordinary places, waiting for someone with the wisdom to recognize its importance. Thank you for joining us on this journey through the remarkable life of Alexander Fleming. His story shows us that sometimes the greatest discoveries come not from careful planning, but from accidents that happen to minds prepared to recognize their significance. If you enjoyed learning about Fleming's incredible discovery, please subscribe to our channel for more stories about extraordinary people whose work has made our world a better place. Remember that you too might make discoveries that change the world if you stay curious and observant about the mysteries that surround us every day.